All right, hi everyone. I'm glad to be here today. And just a little bit about me, I run developer relations at Vectara. And I've worked in machine learning for a long time. And I was fortunate enough to work in the LLM space quite early in 2019. And I also want a big round of applause for Jeff and Hugging Face. I'll tell you the number 14 thing that you didn't know about Hugging Face or potentially didn't know, which is when I started using it, it was just one library. It was called PyTorch Transformers. So those of you who may look up the history. And now it's this whole ecosystem of stuff. So I really am super appreciative of all of that, what that team did over the years. I want to talk about hallucinations. I'm sure you've seen a lot of examples. This is my favorite one recently because they keep changing and they fix them a little bit. But when you ask ChatGPT, about a month ago, I asked, did Will Smith ever hit anyone? He gave me a whole story about he's a great guy, he never hit anybody, he's awesome. And of course, we know what really happened, right? These hallucinations happen and you can find them, more and more. So now, a lot of people ask me about the definitions of hallucinations, right? And so there's a lot of them, and one I like is just when the generated content from your Gen AI is either incorrect or unfaithful to the provided source content. So say GPT was trained on some source content, a lot of web data, and if it's unfaithful for that or doesn't know that, that's when we see these things called hallucinations. Now, I want to talk today a little bit about why do LLMs hallucinate, and then a couple of ways that we can address them, that people are working on to address them. So to explain kind of my view of why LLMs hallucinate, I want to introduce you to this mental model of a knowledge graph. It's a conceptual model. I know in the community of AI, we've talked about knowledge graphs in a different context for a while. So don't take it as the literal sense of that. But after you train a large language model, you have sort of the equivalent of some sort of knowledge graph embedded in its weights. And the way I think about it is when we ask an LLM to respond to any query or any question, think of it as like it consults with its knowledge graph in a way to generate its response. Of course, technically that's not correct. It's just like you heard, it's completing a sentence. But if you think about the knowledge aspect of it, that's how I like to think about it, and this will help me explain the two ways that really LLMs hallucinate. By the way, it's not easy to understand this knowledge graph. So we can't see it, or at least not now. We can't really see what's inside. But we kind of see that it has some understanding of different concepts by sort of querying the LLM and seeing its response. So there's two reasons I want to talk about of why LLMs hallucinate. The number one is you ask it a question, and the answer to that question is not in its knowledge graph. So it can't answer, right? So most LLMs are trained on a big data set, and they're trying to complete the sentence. They're not really very good at saying, I don't know. It's not one of the things they're trained to do. So they try to complete the sentence however they can, and if the knowledge is not there, they'll say something, and they'll probably pick up the most likely response they can find in their weights. And that response may not be true, may not be correct, and that's when you get a hallucination. The other reason is you ask a question, and the answer to the question is in a knowledge graph, but it's something that either is fictional content. Remember, this was trained on Wikipedia and the web and a bunch of different data sets, and there's a lot of fictional content there. So you might get a response that's from a story or a fiction or something, and it's going to be correct for the knowledge graph perspective, but it's going to be wrong. Or, there's a lot of opinions on the web, so you might get an answer that doesn't fit with your beliefs or your opinions, and that happens too. So these are the reasons why we get hallucinations. And let me talk to you a little bit about how people are working to address those. So there's a lot of research going on, as you can see here, and I want to highlight a few of the directions that I see happening. One is people think and experiment with improving the training data. cleaning it up, making it more, have less bias, and things like that. That's a lot of research going on into that, and people believe that clearly would help. The second technique is called reinforcement learning with human feedback. Very well known. I think that OpenAI used that in their model, and a bunch of other research labs are using that. Essentially, the idea of RLHF is to take human feedback, questions and answers, and use what's called reinforcement learning, which is a technique in machine learning with the reward models, to train the model even a little bit further based on those based on that human feedback, questions and answers. And that ends up working pretty well. So that has shown to be a good technique. It's effective. It doesn't solve all the hallucinations, but it gets, things from, like if you look at GPT-3, it had a lot of hallucinations, and GPT 3.5 that we use now, the ChatGPT, has a lot less because it uses RLHF. Outside of that, there's also a lot of work on improving the prompting. So people found, and I'm sure there's a lot of lore on that, and people give a lot of advice of how to prompt your language model to work effectively. So people use custom prompts, and some more researchy techniques have come up that help it deal better with hallucinations, especially when you're asking it to do some reasoning tasks. So for example, I was mentioning a couple, React, Tree of Thought, Chain of Thought, are ways to create prompts and create some help the LLM do better when you ask it to solve a problem. And the last one that I think you heard about almost in every talk here yesterday and today is retrieval augmented generation. That is probably the most common way to address hallucinations. At Vectara, we also called it grounded generation, which is based on the fact that it's grounded in facts, but it's the same thing. We also like grounded generation better because it's a GG, and which is a gaming concept, so it's pretty cool. We like video games. So let me talk now about retrieval augmented generation and explain more how that works and how it helps address hallucinations. So essentially, retrieval augmented generation works as shown here. It's a very simple concept. You have a user query, and you want the LLM to respond, but you want to do it with your own data, your private data, or data that you want it to focus on. So what you do is you get a retrieval engine to retrieve the most relevant facts or pieces of data or chunks, which we'll talk about in a minute, from the data, and ask the large language model to say, please answer this question, but here are some facts that you can use to help you really focus on the right answer. These are facts that are relevant for the question, and they'll help you focus. And so that's what the LLM does. You ask it to do it, and it does it. And the responses are usually much better and reduce hallucination quite a bit. This is very helpful for use cases like a chatbot or Copilot in a certain set of data, or question answering, and a bunch of other use cases. So I wanted to share this reference architecture for retrieval augmented generation. I think I'm going to use my pointer here. There we go. So to walk you through kind of how it works. So there's essentially 2 or 3 flows that I want you to think about. Here we have the data ingest flow. So when you have your own data, you would first take the data, whether it's in a data set or a set of PDFs on S3 or wherever it comes. It could be a Notion or a Jira, wherever you have it. And you're going to take this data and have to first extract the text from the data. If it's a PDF, it's a binary file. You have to extract it. And then you have to do this thing called chunking, because you can't give the LLM the whole document. Imagine you have 10 million documents. You have to chunk it into pieces. And I'll talk about chunking in a little bit. And then you have to run this thing called an embedding model. And what the embedding model does is it takes the chunk and creates a vector of values, of float values. They represent the semantic meaning, if it's a good embedding model, that represents the semantic meaning of that chunk. And we'll see how that's important later on. And then you store it in something called a vector store. So there's open source vector stores, there's commercial vector stores. last time I checked, there was about 54 of them. It's like way too many, in my opinion. But you store the vectors here, and you also have to store the text here. And then you're done with the ingest, essentially. And when a user query comes in, you, again, embed the query itself. So you create a vector representing what's the meaning of the query. And then you kind of ask the vector store, give me the chunks that are most similar. It uses similarity search to that query by looking at similarity between the vectors. I'm oversimplifying here, but that's the gist of it. And all of those relevant results come here. You construct some prompt to the LLM and say, hey, please answer this question with these facts. You send it over to the LLM, and then you get a response. Sometimes there's a couple projects coming up, one from NVIDIA and a couple others that also want to look at the response and give it some guardrails. So oh, I don't want to have some word that is like that or like that. So it kind of do that. But that's generally the flow of things. And one last thing I want to mention is that sometimes the response can also be used to trigger an action. So let's say based on the response, you want to send an email or start a ticket somewhere. So this is for enterprise mostly. And that's where you do that over here. So that's kind of how it works. And a lot of people do it themselves and build all these pieces. And one thing I want to mention about what we do at Vectara is we put it all in a box and make it easy for you to do. So we realize that this is OK when you build a small example with one PDF document. Well, you want to do this at scale. You want to have security. You want to have privacy. It's hard for everybody who wants to do this to be an expert in how you do this right. There's a lot of ways you can make mistakes and get the wrong embeddings and this and this and the other. And so what we do is we have a managed service that, among other things, implements a retrieval augmented generation flow. And all you have to do is send the documents, however they come, into our system. They get indexed. All the flow I showed you earlier in the flow happens here. And then when you run a query, you again send it through the API. You get the response with all the flow that happens in all these steps happening behind the API. And it makes building generative AI applications much easier, much simpler, and you can scale it really, really quickly. All right, so that's the RAG flow. Now, a couple of reasons why RAG works well. One is, again, it is the prime way people use to augment the LLM with your own data. So if you have private data, ChatGPT would never know about this, or Anthropic would never know about this. So that's a common flow for everybody is excited about. It's also private. You notice that we don't fine-tune on your data here. You don't train our models anywhere on here. So this is we just use your data for retrieval and sending it to be summarized. So there's this privacy of the data. It turns out it's a lot more less expensive than if you try to do something else. For example, retraining or collecting human feedback itself is a really expensive process, and usually, more bigger companies can do that, can afford to do that. And lastly, it's also kind of complementary to any model improvements we have. So when the next level of, Anthropic or Llama or GPT comes out, this continues to be a good way to do it. It just benefits from a much better LLM that uses it at the end. Okay, so I want to talk for a couple minutes about doing RAG or retrieval augmented generation right. There's a lot of different concepts and best practices. I can't cover all of them here, but I want to talk about a couple that are important and have recently got a lot of attention and questions in the sort of social media world. And I want to talk about two things that affect retrieval. So I mentioned earlier that we get the facts from the documents and put them through to the LLM. Of course, if you get the wrong facts, it's not really good, right? So you got to get exactly the right facts. And if the right facts are missing, you're not going to have all the facts to give it the most chance of giving you the right summary. And if the wrong facts are included when you send stuff to the LLM, of course, it'll get confused by the noise. So you really want to get the best retrieval engine you can. And so there's two things that come into that. One is called chunking. Some of you may have heard of it. It's something that comes up, excuse me, a lot. And then using a best-in-class embeddings model. So when I talk about chunking, here's an example. When people started using this technique of RAG, and I know this industry is moving so fast, so I could imagine it 3 months ago. This is not, happens very quickly. I'm joking. It's a little bit longer than that. But people started doing what's called fixed chunking, which is shown here, right? So you sort of take a text. This is a piece of text from State of the Union speech, and you say, oh, I'm going to chunk it by 500 characters or 1,000 characters or something like that. And it's a simple technique, but it turns out it's not super optimal, as you can imagine. It breaks sentences in the middle. There's a whole set of other techniques that people have tried to work with. One that I can mention that both our friends at LlamaIndex and LangChain are implementing is sort of like recursive chunking and a bunch of other techniques. What we found, and what's actually implemented in the Vectara works the best way, is actually doing chunking by using actually NLP. So looking at the sentences and figuring out what are the smallest chunks that really work well, that you could, they're small enough that it will match without adding too much noise, but then they won't be too small, so you lose the signal. And so that's how you break things into chunks. It's important to do that correctly. And the other thing is then, when you have relatively small chunks, people are afraid like, well, I don't have enough context. But remember that chunks are moved into an embedding model, which is how you do the matching. So you can still match on the chunk, but when you add this text into the LLM and send it back to give you the answer, you can actually add sentences before and after to give it more context from the document. And that actually works pretty well. So that will be my 2 tips about how to do chunking. Try to do it in NLP. By the way, NLP is not super easy too, because you have different languages and different algorithms. But it's effective and it gives you better results. And then include sentences before and after. All right. Last, I want to talk about embedding models. So I kind of had this box that says, oh, we're going to create an embedding model. What does that do really? It actually takes one of those chunks and creates a vector of floats. It could be 700 or 1,000 or whatever, a number of floats, a vector. It's called an embedding vector. And this is the vector that gets stored in the vector store and gets compared against the embedding of the query to match out. So one point I want to make is, not all embeddings models are created equal. So a lot of people focus more on the LLM itself. I'm going to use Anthropic or Llama or this or the other. But this actually makes sense which embedding model you use. And I want to finish this piece by, we actually, yesterday, I'm glad to share, we announced our new embedding model called Boomerang, which we're very excited about. And there is a blog post here that has a lot more information about it. I encourage you to read it later. But just a little bits and pieces, we did a very extensive benchmark comparing ourselves to a bunch of the other embedding models. And we're doing pretty well, as you can see in these graphs. And I look forward to having the industry as a whole go and improve embedding models for everybody who's trying to use this reg flow. All right. Last thing, I was going to do a demo for you, but unfortunately, I only have a clicker. I can't type, and I can't do anything. So I will invite you to look at this URL later. We have a bunch of demos. Those are sample applications, and there's many of them on our website that demonstrate how to use RAG, what a real application looks like. In this example, we have crawled a bunch of news articles from different sources and ingested them into Vectara. And if I was able to click on one of these or type in something, it would run a query, pull the facts from those news sources related to this question you asked, and give you the answer based on the full RAG pipeline. So I apologize I can't do it here, but I encourage you to look it up later. And with that, I will see if there's any questions. Yes, over here.
So the embedding models, that's independent of whether or not somebody uses Vectera, right? If somebody's using Pinecone, they can still use the Vectera embeddings for doing the RAG. Is that correct?
So today, the embedding models only works within Vectara. You can't use it independently because, as I explained earlier, we have a full stack of managed servers. So we have the embedding models, and we also do the vector store kind of in the middle.
So you don't get the embeddings back when I
No, we give you the, we try to simplify, so we give you the right facts, but you can build RAG and call different summarizers. There's a lot of other ways you can use it. We're, for example, integrated in LangChain and Llama Index, so a lot of people use that to also do other stuff with the results. Yes. Yeah, right here.
Yeah, I have a quick question. So, I can see that like how it works. Like you're chunking text and then you're retrieving the relevant text. But is there, do you know, happen to know any further research like having like LLM like summarize and feed into a text and like retrieving that later on, or like more creative? Like it seems like this is first step. There's further steps you could do to create annotations to retrieve, right?
Great question, and maybe I'll try to repeat it for everybody. I think you were asking, you retrieve and you summarize with the LM, is there more stuff that will happen in this flow that's more complicated? And I think the answer is yes. I think we're just starting with RAG. One of the things I've seen, for example, is people taking the RAG result and using it and asking a subsequent LM request to do something else with it, like summarize it in a different tone, like maybe I'm explaining like I'm 5, ELI 5 example, or more importantly in enterprise, summarize, you can take a bunch of these RAG results and connect them together and ask it to summarize the whole thing. So there's a lot of things that, creative ways people can use it, yes. Sorry, yes, over here.
Thoughts on leveraging like signals from the information retrieval line of, for example, like if you want to use this in an enterprise setting, not all documents are created equal, right? The documents written by maybe legal and complaints team may be more important, even if the same information or similar information is contained in different documents.
Great question. The question is like, how do I'll translate, how do I give different documents different weight in the results? And so again, there are a lot of ways to do that at Vectara and in other platforms, but I think traditionally what people do is, first of all, you can have like a metadata. So first you can filter, which is important, but at Vectara too, we have something, a feature where you can actually give weight to, in the results to different documents in the same way you mentioned. And for example, another example would be when you build an application and somebody has like a thumbs up and thumbs down, sometimes you want to have the things that got the most thumbs up to be best. I think you mentioned also like just importance, pre-notion, like it's regulation or something I wanted to influence more. So yes, there's ways to do that. Let me get something from that side, yes. Can you speak a little louder, or sorry? So as I don't know if I can go back here, but traditionally the question was is there a loss to measure, I guess, the performance of different embedding models? So I think the way you measure them, excuse me, and I invite you to look at our blog because our team worked really hard on this, is different metrics. It's not measured like loss, like how you train a model in the traditional LLM. It's a measure of question answering results, usually things like MAP and MRR and metrics that are more common in the information retrieval space. Anything? Yeah. Mm-hmm.
So how does the, first of all, the NLP extraction and I guess the calculating and embedding work with things that are more structured data? Like Jira issues, for instance, have like a bunch more metadata and it's not like prose where you can kind of go in and like, oh, paragraph X matches. So it's like, how does that work?
Great question. So the question is like, how do you do the NLP extraction or the chunking, whatever chunking strategy you do, if it's Notion versus a PDF or something? So again, with Vectara, you know, we have, you can upload files of different formats. If the format is like a PDF or text or HTML and a bunch of supported formats, and there'll be more to come. We do this automatically for you, but you can always extract, if it's not supported, you can always extract the data on the client side while you ingest and send a pure text to it as a text file or HTML, and it'll chunk that anyways on our side before it creates the chunks. Yes, over there. Wow, good question. What is the implication on society as news organizations start to invent news? Is that kind of what you're asking? All right. Wow. Oh man. No rag in this question. Yeah. I will follow what Jeff said here in the last session. I'm a true believer that there's more good than bad in use cases of AI. There's wonderful things that we can create and help a lot of people. I hope that we as a society and a set of regulators find it in us to quickly move to be able to support the good, and whoever wants to do bad with it, you know, punish them or reduce their ability to do that. Yes, I think it's one of the risks. There's other risks. There's risk in healthcare. There's risk in, you know, things like that. But that will be my statement there. Yes. So the question is, like, all of my data is actually in a database in Snowflake or in Databricks or where have you, or Oracle or Microsoft SQL. Do I have to move all the data over to here? Great question. I think right now, most implementations of RAG require you to do that. You know, you can imagine that not all your database is all text, so you figure out where it is and you extract the text and you send it over there. But I could see a future where some of it will actually be available inside sort of, let's say, the Snowflake environment or the Databricks environment or what have you, and closer to the data implemented in there. So I guess we'll see. Yeah. One more. Okay. Go ahead.
Yeah, I had a quick question. So you showed the news RAG, right?
Yeah.
Considering the copyright issues of having news data in the training set, is there any implications for using it for RAG as well, or?
So the question is there any copyright implications of using? These are all demos that we put up just for demonstrate our applications. It's not something we sell. But if you use news for, I'm not a lawyer, but if you use any material that you're not supposed to have access to, then I think you should, I would advise talk to a legal counsel. Yes. Okay, one last one, sorry. Yeah. Oh, great question. So he was asking, a lot of times when you have Notion or Google Drive or what have you, whatever data of the enterprise that has access control, how do you persist it in RAG? So I know we're out of time, so I'm going to give you a quick answer, and feel free to catch me up at the office hours later on. But one, it's really complicated. Now, if you use a regular model like an LLM or fine-tune LLM, it's almost impossible. But with RAG, it is possible to do it. It just takes a lot of work to do. And the problem, right, is you have an answer, and you have to make sure that no piece of data that was used in RAG or nothing that flowed through was actually something you, for example, wasn't supposed to see by your permissioning. So great question. And I apologize, we're out of time. I know there's lunch waiting outside. I will be over that other side if you can wait with lunch a little bit and have questions. And thank you very much for having me.